solving number 1, and we're using the substitution method. Okay? You have to know both methods for your test. Okay, so this is the substitution method only. Thanks for visiting.
What scent is that?
It's a mixture of scents. Is it bothering you?
No, it smells like lemon. Nah, it just smells like it smells like my kindergarten classroom.
Because of how
Like, you know, it's like nostalgic kindergarten classroom. No, that's what it smells like. Nostalgic kindergarten classroom. Smells, yeah.
the power off over the weekend, my refrigerator got smelly, and now I need to get rid of that smell. Okay, so how do we solve this using the substitution method? I'm looking at number 1. Yeah, we got to get back into gear here, right? I want to solve this using the substitution method.
Oh, so you can plug in negative.
No, you can't plug in it, Layla.
Subtract the K.
Subtract a K. So why am I subtracting the K?
You can either subtract the K or the J, but still leave one variable.
Right. We want to isolate one of the variables. So when we look at this equation, this system of equations, I have to decide which variable is easier to isolate. Okay. And looking at this, I'm not going to work with the first equation because I'm going to have to do more work to isolate one of the variables. So I'm going to work with the other equation. And in this case, the J or the K would be fine. I'm going to try and get the J by itself. Okay, so I want the J by itself. So that means I need to get rid of the K, so I need to move it to the other side. So we're going to subtract K from both sides. So we get J equals negative K plus 14. Is everybody okay with that?
Yeah.
Okay. Now, here's the mistake that I see a lot. Once we get that, we got that using the second equation. We have to plug this into the other equation. If you plug it back into this one, you're going to get 0 equals 0. So it's not going to work. You have to plug it into the other equation. Okay? So we're going to take this value of J, and we're going to put it right here for that J. So we have 2 times J, but what does J equal? Negative K plus 14. Minus 3K equals 3. Okay, now we're just going to go ahead and solve that. So I'm going to distribute that 2. So we get negative 2K plus 28 minus 3K equals 3. What now?
You can combine like terms.
Yeah, combine like terms. So we had negative 2K, negative 3K. What's that equal?
Negative 5.
There you go, negative 5K. Right?
You just do another one. You just like skip minus.
I did what?
Like you just like skip like a whole step for me in my brain. I just didn't comprehend it. Not gonna lie.
Which part? Where I got from here to here?
I'm not from. I went to like 2 with the parentheses.
How I got from here to here.
Yeah.
All I did was distribute the 2.
And I'm talking about like the.
Oh, how I got there.
Yeah.
Okay, so it's 2J, but we just figured out what J equals. J equals negative K plus 14. So we take that negative K plus 14 and we stick it in for the J. Yes,
That's what the substitution.
Okay.
that's where the word substitution method comes from. Yes. Okay, we're going to subtract 28. So we get negative 5K equals negative 25. So K equals 5. All right, so, but I need to find a J and a K. So how do I figure out J?
So you plug in K when J equals K.
Yeah, exactly. I know that J equals negative K plus 14, right? I did that right there. So we're going to put the positive 5 in for K. So J equals negative 5 plus 14. So J equals 9. you go. Okay, it's like 110 degrees in here. It is so hot. Man, oh man. Get all warmed up doing that. Huh.
I need to go. What?
Okay, questions on this problem? Yes.
Sometimes the whole equation phrase can be like a variable.
Wait, what are
Yes. Yes.
Alright, so like are 90% of them like gonna be a phrase for a variable or not?
That's what substitution method is.
No, so it's gonna be just straight equation, not like single numbers for the variables.
Sometimes you'll see single numbers, but majority of the time it'll be an expression like that. Okay? All right, let's do another one. Ooh, man, hot. Okay, let's do number 4. Yeah, let's do number 4. So looking at number 4, which equation is going to be easier to work with? The top one, right, because it doesn't have any variables in front of it. So we've got negative W minus Z equals negative 2. Okay, I put that little line through the Z so it doesn't look like a 2. Okay. Do you want to isolate the W or the Z?
The Z.
Want to do the Z? Okay. Doesn't matter.
Do the Z.
All right, so how would I isolate the Z?
Add it to the other side.
You add the W to the side.
Add the W to the other side. Good. So we get negative Z equals W minus 2. Okay. I still have not isolated the Z. I've isolated negative Z. So how do I get it to be Z?
times it by negative?
Or divide by negative 1. Divide everything by negative 1. Okay. So we get positive Z equals negative W plus 2.
Why does that have to be positive?
Because when I go to substitute into this equation, this is a positive Z. So I'm going to take this and I'm going to put it in place of Z in this equation. So I have to know what Z equals, not what negative Z equals. Okay. Yep, good question. All right, so now we're going to go to the other equation, right? So we have 4W plus 5Z, but Z equals negative W plus 2 equals 16. Everybody good? Okay, so we're going to go ahead and distribute. Well, this is going to be minus 5W because that's a negative W. Plus 10 equals 16. So we have negative W plus 10 equals 16. Subtracting 10, we get 6. Now we have to divide by negative 1 again, so W equals negative 6. So there's one answer, but I still need to know what? I need to know Z. Yeah. So we can go back here because we know that Z equals negative W, so that's negative 6 plus 2. So we get positive 6 plus 2. So Z equals 8. Okay. Okay, so any questions?